Hi friends, good morning. This is Dr. Munaswamy, Professor, Department of ECE. Today we are going to discuss the SSB modulation introduction in terms of the frequency and time domain, and also what are the basic components, internal components of the SSB modulation introduction. So last class we discussed about the DSBSC wave modulation as well as the demodulation techniques. Today, so what is the need of the SSB modulation compared to the DSBSC wave? So how it will be efficient or effective than the DSBSC wave? So what is the actual need of the SSB? SSB stands for single sideband modulation technique. Single sideband modulation techniques. So you can see the diagram, frequency spectrum of the, so by the application of the equation SSB modulated wave, by applying the Fourier transform, we can get the spectrum of the SSB modulation. So DSBSC is nothing but suppressing carrier signal and allowing only two sidebands, upper sideband as well as the lower sideband. So whereas coming to the SSB modulation, the name itself indicates single sideband, only single sideband only we are transmitting. So that is either upper sideband or lower sideband. There are two sidebands are there, upper sideband as well as the lower sideband. Based on our requirement, you can transmit the any one of the SSB modulation sideband. So that is maybe upper sideband or maybe lower sideband. So why it is a SSB modulation is needed? So by seeing the diagram, so with reference to the carrier position, both lower sideband as well as upper sideband is mirror image to each other, symmetrical to each other. So that means, so the signal or the information available in the upper sideband is mirror image or symmetrical to other sideband, that is lower sideband. So that means, so there is no need of transmission of both sidebands. We can transmit any one of the sideband, lower sideband as well as the upper sideband. So you can retrieve the information signal of all the sidebands, two sidebands. So because of the symmetrical nature or mirror image to each other, with the support this property, symmetrical property, we can retrieve with the help of the one of the sideband. Suppose you transmitted the lower sideband, so that automatically you can retrieve with the symmetrical property the other sideband, that is upper sideband. So that is the main advantage of these two sidebands. Both sidebands are of DSBSC wave are symmetrical to each other. With the property of the symmetrical, we can transmit the only one sideband. With the transmitted sideband, with the property of the symmetry, we can retrieve the other sideband also. That means we are getting both the upper sideband as well as the lower sideband. So automatically we can get the entire information. So that is the main advantage of the SSB modulation. So with the help of the one sideband transmission, we can get the information which is related to of both sidebands, upper sideband as well as the lower sidebands. So that is the main advantage of the SSB modulation compared to the DSBSC waves. Automatically, the requirement, so that may be power, bandwidth requirement and mathematical design, everything will be simplified because we are transmitting only one sideband. So automatically, the power consumption will be reduced compared to the DSBSC wave as well as the AM modulation. In case of the AM modulation, we are transmitting both sidebands along with the carrier signal. Whereas coming to the DSBSC wave, we are suppressing the carrier signal and transmitting only two sidebands. That is the upper sideband, lower sideband. Whereas coming to the SSB modulation, we are transmitting only one sideband here. So automatically there is a reduction of the bandwidth as well as a reduction of the power consumption, and efficiency also increases. So that is the main advantages of this SSB modulation. Then coming to the mathematical expression for the single sideband modulated wave. So already you know that from the beginning of the AM modulation, the modulated signal M of t E is given by AM into cos 2 pi FMT. So AM is the amplitude of the modulating signal, FM is the frequency of the modulating signal. Then coming to the carrier signal, so C of t equal to AC cos 2 pi FCT. Here also AC is the magnitude of the carrier signal and FC is the carrier signal frequency of the carrier signal. So these are the input signal for generation of any modulated wave. It may be amplitude modulated wave, it may be DSBC wave, or it may be SSB, single sideband modulated wave. So these two are the input signals for a generation of the modulated waves. So by the operation of the modulation. So carrier signal C of t and modulating signal M of t. Now we have to generate with the help of the mathematical expression what you have discussed in the last class for the DSBC wave as well as the AM modulation. So there are carrier signal, three components are there, carrier signal and modulating signal, combination of both carrier signal as well as modulating signal, that is upper sideband, lower sideband, three components are there. So one component carrier is suppressed. In case of the DSBC wave, we are transmitting only two sideband. Whereas coming to the SSB, single sideband modulation, so it will be any one of the one sideband. So take the upper sideband means FC plus FM. So upper to the carrier frequency. So that we are getting the AM AC by cos 2 pi FC plus FM is upper sideband frequency. So it is upper sideband. Expression for the mathematical expression for the upper sideband of SSB equal to S of t equal to AM AC by 2 cos 2 pi FC plus FM is the upper sideband. Whereas coming to the lower sideband is the difference. So S of t equal to AM AC by 2 cos 2 pi FC minus FM is the lower sideband. So below to the lower carrier frequency FC minus FM. Above to the carrier frequency we are getting the FC plus FM. So above to the carrier frequency is always upper sideband. Below to the carrier frequency is lower sideband. So these are the standard mathematical expressions for the lower sideband as well as the upper sideband. So you have to remember all the expressions: AM modulated wave, DSBSB modulated wave, and also SSB single sideband modulated. Once you have the AM modulated wave, you can simply remember that remaining two. So suppression of the carrier signal will get the two sidebands, and another suppression of the one sideband as well as the carrier will get the SSB single sideband. So that is enough. You have to remember. Then coming to the what is the bandwidth requirement of the SSB. So in the last class of the AM modulation techniques and DSBC wave, so there we are transmitting the two sidebands. Bandwidth nothing but it is a difference between the two frequency components. High frequency component minus lower frequency component. So FC minus, so that is based on the frequency available to highest frequency component and lowest frequency component. The difference between these two frequency components will give us the bandwidth requirement of the any modulation. So take the AM modulation, the bandwidth requirement is 2 FM, where FM is the highest frequency component of our modulating signal. Similarly, coming to the DSBC wave, here also we are transmitting the two sidebands, so upper sideband and lower sideband, so that we are getting the both cases. So that here also the bandwidth requirement for the DSBC wave is 2 FM only. So whereas coming to the SSB, here we are not transmitting the both sidebands. We are transmitting only one sideband. It may be upper sideband or lower sideband. If it is upper sideband, FC plus FM. If it is lower sideband, it is a FC minus FM. So that the bandwidth requirement is become less, half to the requirement of the DSBC or AM signal. So that we are transmitting only one sideband. So the total requirement of the bandwidth of the DSBC wave is 2 FM. So we are transmitting here only one sideband, upper sideband or lower sideband. So we are getting the by 2, we will get the FM only. This is the bandwidth requirement of the SSB modulated wave. So FM only, where FM is the highest frequency component of modulating signal. So for the case of DSBC wave and AM modulation, the bandwidth requirement is 2 FM, 2 times the highest frequency component of modulating signal. Whereas coming to the SSB modulation, here we are transmitting only one sideband. It may be upper sideband or lower sideband, so that we are getting the half of the the requirement of the DSP wave, so that we are getting the 2 FM by 2 only FM only. So that is the main advantage of the SSB. Bandwidth requirement is also very less, half of the AM modulated wave or DSP wave. That is, you have to remember, you have to observe what is the difference of the bandwidth requirement for both the DSP AM with the SSB modulated wave. That is FM only. Then coming to consider the SSB standard power relations. So how we are going to calculate the power relation? We have to already discussed in the DSP wave, similarly AM wave also. So based on here we are transmitting the only one sideband. In case of the AM modulation, we are transmitting 3 components. That is the carrier, upper sideband, lower sideband. Whereas coming to DSP only ESP, upper sideband and lower sideband. Here coming to this LSB or ESP in case of the SSB only. So either of the lower sideband or upper sideband only we are transmitting. So that power requirement is only the transmission of the power requirement for the transmission of the one sideband only. So that we are getting total power PT equal to PESB upper sideband if we are considering transmission of the ESB. If you are going to consider the transmission of the LSB, it will be equal to PLSB. So that DSB case we are getting summation of both the ESB as well as the LSB. Whereas coming to this total power requirement of the SSB only one sideband. So we are going to get it is equal to total power of the SSB transmission equal to either of the ESB or LSB power requirement only. That is, the power requirement is also very less compared to the remaining 2 modulations. So it is also another advantage of the SSB. So here you know that already for a purpose of the calculation of the power, P equal to VRMS square by 2, where ERMS equal to VM by root 2. So you will get this one. So overall already you have discussed in case of DSP wave for both cases of the upper sideband, lower sideband. So you are getting this one. So AM square AC square by 8R for the case of the ESP. Similarly you are going to get for the LSB AM square AC square 8R. So overall the total power requirement of for the transmission of the single sideband modulated wave PT is equal to PSB or PLSB is equal to AM square AC square by 8R only. So these are the fundamental mathematical expressions for the calculation of the power in case of the SSB modulation. So then coming to the advantages and drawbacks of the already while discussing all the modulation techniques, we have compared all the modulation AM and the DSP and SSB. Later on, you can also see the VSB, vestigial sideband, under modulation. So coming to the advantage of this SSB modulation, so bandwidth requirement is very less compared to the AM and DSP. Already we discussed. So in case of the AM and DSP, it is 2 FM, whereas coming to the SSB only FM only. The transmission of the more number of signals is allowed. So it is bandwidth requirement base. Power is also saved. Less power consumption, we can save the more power compared to the AM and DSP. So high power signals can be transmitted. In case of the SSB modulation, you can have the high power signal transmission. Less amount of the noise is present. Noise is very less compared to the DSP wave and AM. The signal fading is very less in case of the SSB modulation. So whereas DSP wave, we are transmitting the both sideband, upper sideband as a lower sideband. So there is a reference of the carrier. So we are going to have the both upper sideband, lower sideband. So there may be a chance of getting the fading in case of the DSP wave. Okay, so that is the main advantage of the SSB. There is no fading in case of the SSB modulation. So coming to the drawbacks, the generation detection of the DSP wave is complex. So because you have to arrangement of the generation of the carrier signal locally, local oscillator. Similarly, another is we are receiving only one sideband. With the help of the symmetrical property, you have to retrieve the another sideband. Suppose we are receiving the one sideband of upper sideband. With the help of the symmetrical property, you have to retrieve the another lower sideband. So that is also complex, somewhat difficult for retrieving the original signal of the SSB modulated signal. Then coming to the quality of the signal gets affected unless the SSB transmit receiver have the excellent frequency stability. So frequency stability is very important. Unless this frequency stability, we are unable to retrieve the original signal. Then coming to the applications. So for a power saving requirement and low bandwidth requirement, we are going to use the SSB modulation. So where we are going to power saving is more required, then you can go for the modulation of the SSB. Similarly, bandwidth requirement, where the bandwidth is very less, requirement is there, then you can go for the SSB modulation. In land, air and mobile communications, we are going to use this SSB modulation. Especially in case of the point-to-point communication. Point-to-point communication means we can provide the more high-speed transmission. And suppose you take telephone point-to-point communication, there is a line, fixed line between the one point and the point, so that you can easily transmit the entire signal at high speed without any disturbance. That is the main advantage, point-to-point communication by the SSB modulation. Then in radio communication also. So coming to the radio communication, audio signal is transmitted with this SSB modulation. So bandwidth requirement is very less, power is also, consumption is very less, we have more power saving. So the point-to-point communication is also very useful by the help of this SSB modulation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.